Hello everyone, am I audible?
Yeah, yes, Sudhanshu, you're audible.
Okay, fine, just start. Okay guys, so I think in last class I was talking about pandas, right? Virat, can you please confirm?
Yeah, yes, Sudhanshu, you're talking about pandas.
Okay, fine. So in this class, I'm going to talk about a NumPy package. Okay, fine guys. So I think in last class, so I was talking about a pandas and we have discussed many things in terms of a pandas. So in this class, I will talk about what is NumPy and what is the uses of NumPy package and what kind of data we'll be able to handle inside a NumPy. So let's try to understand that what is a NumPy first of all. So I'll try to do an import over here. So import NUMPY as NP. So here you will be able to find out that I'm trying to import this NumPy NUMPY. So it's nothing but a numerical Python. So NUM means numerical and Py means Python basically. So this NumPy was not available inside a Python package or as a part of a Python package, I would say. So basically, there is a tool I would say called as a Matplotlib. It's not like a MATLAB basically. So there was a tool called as a MATLAB, not a Matplotlib. Matplotlib is basically a library for a visualization. So MATLAB is a tool which has been used for a different kind of a simulation or different kind of a software testing or different kind of a neural network as well. So before a 5 year back or 10-year back, so people have been using, and even when I was in my college life, so I was trying to write some kind of a paper at that point of a time, so even I have used a MATLAB. So MATLAB as a tool to build a neural network. So because at that point of a time there was no TensorFlow, there was no PyCharm, Thenos or Cafe which was available as an open source. So fine. So basically that was a numerical package which was available inside MATLAB. And what people have done is, so they have just replicated the entire package inside a Python. Same numerical package they have replicated over here, keeping these things in our mind that if we are trying to do a signal processing, or if we are trying to do a image processing, or if we are trying to do any kind of a text data processing as well, so generally system will be expecting a kind of a array or kind of a matrices. So unless and until you will not be able to convert your data in a form of a arrays or in a form of a matrices, you will not be able to perform those kind of operations. So NumPy is basically a numerical Python package where you will be dealing with majorly an array or the matrices, or mostly array, because matrix is a subclass of an array itself. So again, we are going to talk about different kind of operations or different kind of a data manipulation with respect to a NumPy package plus a data conversion as well. So NumPy package just understand arrays or matrices, and like I told you in a very beginning that there is no such array concept which exists inside a core Python. And yes, that is true. So far so forth we have not seen even a single array element in our discussion. So there is a list element which is available, but there is no array element which is available. So like I told you that this array kind of a element is available inside a NumPy, and let's try to discuss about that. Let's try to build our understanding. So here I'm just trying to import NumPy, because by default this NumPy libraries will not be available in your current import or in your current session. Once you are going to import it, after that for sure it will be available. So yes, it is now it's available, and NP is nothing but it's just a alias which I have given. So you can try to give my name or you can try to give your name, doesn't matter at all. So it's just an abbreviation of a NumPy which I'm trying to take in this particular place. Now what I will do is, let's suppose if I'm going to create a list, let's suppose A is a list, and then inside my list I have a 3 comma 4 comma 5 comma 6. This is the data. Now as we know that if I'm going to check a type of this data, so it is going to give me basically a list data. It's completely fine. Now what we can do on top of this one is, so if I have to convert this data into a array format, into a NumPy compatible array format, so in that case I can try to call NP, which is nothing but an alias of a NumPy, like we were using alias for a pandas is equal to PD, and then NumPy dot array I can try to type over here, and I can try to give a value is equal to a, means I'm trying to pass list inside a numpy.array. If I'm going to execute it, it's completely fine. You will be able to see a notation as an array over here. So this is a notation of an array that you will be able to see. So I have converted my list into a array format in this way. Now, so here, if I'll try to check a data type of this one, type of this one, so it's basically a ND array. So you will be able to find out that it's a NumPy compatible n dimensional array. So ND array means n dimensional array. It is trying to build it for me. So it's completely fine. So I'm able to build an array out of my data set. Now what we are going to do is, so now I will be showing you a different kind of a manipulation. So here it's a very basic thing, like you will take an array and then you will take a list, and then you will be able to convert those lists in terms of or in a form of arrays. It's completely fine. Plus what we can do is, so let's suppose if I'm going to take a list where I have an integer and I have a floating point number. Now what will happen if I'm going to take an integer? So I have a 3 4 5 6 as an integer, and then I have what? So I have basically a floating point number over here. Now if I'm going to execute it, it's completely fine. You will be able to see some kind of a changes in your output. You will be able to find out that it is trying to perform upcasting. It is trying to perform upcasting automatically. So we had just 3, but it has converted these things into 3 dot, means a floating point number. So finally it has converted everything into a floating point number. This is called as a upcasting. So if you are going to take some element inside a numpy or some element inside a list as a floating point number, and if rest of the element is available into an integer, by default, whenever you will try to convert your data into an array, it will try to perform a upcasting. This is something which is going to happen by default. You don't have any control over to it. Again, in a later stage, you will be able to do a typecasting, and you will be able to convert all of your, like a floating point number into an integer. That is possible. But here, so by default, it will be able to upcast your data set. Again, array wise, if I can talk about, so np.array, and maybe I can try to pass a nested list over here. So I can try to pass a list of a list over here. So this is a list. Inside that I have 1 comma 2 comma 3, and I have another list, let's suppose. So I have another list, and in this list, let's suppose I have a 3 comma 4 comma 5. If I'm going to execute it, so again it has converted my data into a array inside array. So basically I have 2 array inside one single array. This is how you will be able to understand it. So I have an outer array, and inside that again I have a 2 array. Or if you will try to understand in a layman way, you can try to understand in this way, that here, so we have 0 1 2, and here we have 0 1. So we have 2 row and we have 3 columns. Let's suppose if I have to access this element, so how I will be able to access this element? If I'm going to give a coordinate, or if I'm going to give like indexes of 0 0, I will be able to access 1. If I'm going to act like give 0 1, I will be able to access this one. This is how you are supposed to understand a numpy array or n dimensional array. So let's try to do it, and let's try to understand it. So let's suppose I'm going to store this particular value inside a variable called as v, and this is v is nothing but this one. Now if I'm going to write v of 0, then I will be able to get this entirely first element. V of 0 means 0th row I'm able to access. Now if I'm going to give v of 0, this is what we have discussed. So for sure you will be able to get this one. 0 of 1, so this one. 0 of 2, this one. So this is how you will be able to get a data. You will be able to access a data from a NumPy array. So if you have a multi-dimensional array, this is how I will be able to access a data. Apart from that, so if I will try to check, if I'll try to check v dot shap shape of v. Now, what is the meaning of shape? Shape means number of row and number of columns. So shape is an inbuilt function which is available inside a NumPy. So suppose if I'm going to call shape of this data, this particular data. So as we know that we have a we have 2 row. So that's the reason we are able to get 2, this one and this one. And we have basically 3 columns. So we are able to get these 3, as simple as that. So this is what shape is going to return. And these concepts are very basic, but at the same point of a time, a significance of these concepts are very much high. Once you will try to process your images, or maybe some kind of a sensor data, some kind of a textual data into a deep learning with the help of a neural network, or even into a machine learning, you will be able to understand that in a core, in a heart of each and every processing, so it is trying to convert everything into a numerical array format or a numpy array format, and then it is trying to process it. So again, so sometime it is going to give you some kind of a shape issue, or sometime it is going to give you some kind of a format issue. So unless and until you don't know a numpy in a better way, you will not be able to debug all of those things. So fine guys, I'm able to get a shape over here. Now what I will try to do is, so v dot dim, I can try to execute, or let's suppose I'm going to create one array. So np dot array array, and then inside that, so maybe I can try to keep some kind of a element. So if I'm going to execute it, this is the simple array which I'm able to get. Now if I look into this array function, you will be able to find out that number of dimension which is given. Dimension is given over here. So by default, dimension will be equal to 0. Now let's suppose if I wanted to keep dimension, so ndim is equal to, so ndim is equal to, let's suppose if I'm going to give 2. Now what will happen in that particular case? Let's try to understand it. Sometime, so it's completely fine if I'm going to give dimension is equal to 2. So in that case, you will be able to find out that it is trying to give me 2 bracket over here. It is going to give me 2 bracket over here. This is what happens in case of a number of dimension is equal to 2. Now let's suppose if I'm going to give a dimension is equal to 20, you will be able to find out that it has replaced a 20 bracket before and 20 bracket after. Whenever you will try to do a image processing, these things are very much important, because if I'll talk about a matrix multiplication, because this is what happens in general into a neural network. So if I'm talking about a matrix multiplication, so unless and until you are very sure about these kind of a concept, you will not be able to do lots and lots of time a debugging, where you will be able to get an issue for sure. So I will be able to change a dimension as well for a particular array. So if I have a array maybe having a 1 dimension, so I can try to change these things into a 2 dimension, or into a 3 dimension, or into a multiple dimension, doesn't matter at all. Now so I can try to create a array np.array, and then maybe I can try to give a list. We have already seen that how I can try to change a dimension. Now so I can try to change data type as well. Data type is equal to, maybe I can try to write complex. So in a very first class, we have seen that complex number is a kind of a number where you will be able to get a real data type, plus you will be able to get some kind of a imaginary data type. And for imaginary data type, notation will be equal to j. Suppose I have this data type 1 plus like a 2j. So 1 is nothing but it's a real number, whereas 2 is nothing but it's a imaginary factor, and j is nothing but it's a notation. It's a notation for a imaginary number or a complex number altogether, you can say. So it's completely fine if I wanted to like convert all the data into a complex number. So as we can see that complex part is equal to 0. Complex, we don't have a complex part as of now. So what will happen in this case is it is going to add a complex number by the factor of 0 over here. So still data is same. The only thing which I have done over here is, so I have changed a data type in this particular place, and I will be able to get a complex number. As simple as that. This is what you will be able to get. Again, so in last example, let's suppose if I'm going to take like one list with a 3 number, and other list I have which is having like a 2 number. If I'm going to convert these things, you will not be able to get a proper array. It will be able to convert into a n-dimensional array, a multi-dimensional array. So only in a case of if your all the list element is having a same kind of a shape. If shape is different, if length of the list is different, so in that case you will end up getting this kind of a data. So most of you are going to get this kind of a result for sure. This is a normal result, I would say. This is what you can expect. So it will not be able to convert your entire list into a array. Yes, that will be an array, but it will not be able to convert these things into an n-dimensional array. unless and until size of the list that you are going to take inside the array is not equal to same. In case of a multi-dimensional array, when you are going to pass a multiple list, only in that case, I would say. So fine, till this point, so we have discussed. Now let's try to understand one more thing. So I'm going to take an array, so maybe I can try to write like a np a over here, and then I can try to take one list in this particular place. Just try to focus over here for some time. So I'm trying to take like a 3 comma 4, and then I can try to take maybe like a 5 comma 6 over here. That's completely fine. So I'm trying to take a array over here and take basically like a list which I'm trying to convert into an array. That is completely fine. I'm able to do that. But inside a list, so instead of taking a list, I've taken tuples. So it's completely fine. If I'm going to execute it, I will be able to convert this entire data into a array. This is actually array. So whenever you are going to pass a list of the tuples or list of the list, in both the cases, you will end up getting this kind of a data without any if and but. It's completely fine. You will be able to get it. Now, one more thing I wanted to discuss over here. So in last example, I was trying to give data type is equal to complex. You can try to give data type is equal to integer, or maybe a string you can try to pass, maybe a floating point you can try to pass. Here, I will be using something different, something completely different I'm going to use. So data type, and our data type is equal to, maybe I can try to mention a list over here, and then I can try to mention like two tuples over here. So just like a tuples that we have taken in this particular place, and in a first tuple, what I will do is, so in a first tuple, I can try to say that, okay, so a, so I can try to say a, and a comma, and again a comma lesser than I4. This is the new things. This is the new notation that you will be able to get. And in the second one, what I can do is I can try to write like a b over here, and b comma, and then I can try to mention maybe lesser than equal to 2, lesser than I2. I can try to mention. So, so far, so forth. So far, so forth. You must have seen that I was talking about integer. I was talking about float. I was talking about a str. I was talking about a boolean and complex and a different kind of a primitive data type. That is completely fine. There is no like a if and but with respect to that. But here, I'm trying to define a data type in a bit different way. Here, I'm trying to define data type in a completely different way. And I think this is not an approach that we have seen so far, so forth. What is the meaning of that? Let's try to understand it. What is the meaning of this particular data type notation? So here, as you can see that you have taken basically a list, and inside a list, so you have a tuple. So we have basically a list of the tuple element. That is completely fine. Inside every tuple, I have two elements. So I have like a element A, I have an element B. Let's suppose again I have element A, element B. Just for the reference, I'm trying to talk about that. Now here what we have done is, so as a data type, so we have mentioned A is equal to I4. Now there is no such A which exists for sure. It's just a reference, means whatever element that we have inside a tuple, it will try to treat that as a B, C, D, whatever you wanted to take, just take it. There won't be an issue. Again over here, so I have taken B, means whatever data which I have available inside a tuple, so we'll try to take these things as a B. So it's completely fine. We have taken A and B, so it will try to consider this as A, this as B, this as A, this as B. Fine. Now for A, we have defined this as a data type. For B, we have defined this as a data type. This is what I'm trying to perform. This is what I'm trying to do over here. So for A, I4 is a data type, and for B, so basically I2 is a data type. Let's try to verify that what is the meaning of this I4 and what is the meaning of this I2, which I'm going to consider. So what kind of a data type this I4 and I2 is? I will try to understand that particular part. So if I'm going to execute it, it's completely fine. I'm able to get my array along with my data type. So the syntax wise, there is no issue. There is no problem. I'll try to store these things maybe into a variable called as n. So let's try to store these things inside a variable called as n. And then what I will do is I will try to access a data n of 0. So n of 0 means what? So let's suppose if I'm going to execute this part, let's suppose if I'm going to execute just this particular part. So I'm supposed to pass a bracket over here. So if I'm going to execute this part, so if I have to access this element, this element is available at 0 of 0 position, 0 1 0 1. So 0 of 0, I will be able to access this 3. So what I will do is I will try to access this 3, and then I will try to check its data type so that I will be able to understand a meaning of I4. Just try to focus over here for 5 minutes, because you will not be able to understand this particular mapping if you are not going to focus for at least 5 minutes. So here I will try to access basically 0 of 0. If I'm going to execute it, I'm able to get this particular 3. It's completely fine. I'm able to access it. But it's completely like I'm not interested into just access of the data. I'm interested into like a data type. So type I can try to type over here, and you will be able to find out that it is representing an integer 32-bit. It is trying to represent an integer 32-bit. Let's suppose I will try to access 4. So 4 is nothing but 0 of 1. So I can try to do a type of n of, I would say, like a 0 of 1, and in this way you will be able to find out that it's representing an integer 16. Now, what is a meaning of this? So as we have already discussed, that it will try to map this first element of a tuple with A and a second element of tuple with B. For A element, means for 3, we have given data type is equal to I4. Now when I'm trying to check this data type, it's basically representing an integer 32-bit. And when I'm trying to check a data type of B, means a B element, so it is trying to give me integer 16. So inside a NumPy, you will be able to find out that we don't have only a integer. We have integer 16-bit, we have integer 32-bit, and we have an integer 64-bit as well. So here you will be able to find out a primitive data type of data type. So it's not only an integer, so far so forth. Even in other programming languages, you will be able to find out just a data type. But here you will be able to find out that it is possible to create an integer just with a 16-bit, just with the 32-bit, or just with the 64-bit. And again, it depends upon the big Indian and little Indian notation. So I think if you are passed out from the computer science background, so you will be able to understand this big Indian or little Indian notation, or you might have heard about this particular word called as big Indian or little Indian notation. So based on that, since this data type has been defined, so based on the system, so maybe I can try to take this data type. But again, it's not a major concern, I would say. So just for the information, so I'm just trying to like give you this kind of example, so that you will be able to understand that there is not only integer data type which is available. There is a 16-bit, there is a 32-bit, and there is a 64-bit which is available. Now let's suppose if I'm going to change these things to 8. Now what will happen in this case? You will be able to find out that now it's a 64-bit basically. So I8 is going to represent, this is just a notation. So I8 is representing 64-bit. Let's suppose if I'm going to make these things as a 16. So what will happen in that case? There is an error. So it will not be able to understand 16. So 2 is available, 4 is available, and 8 is available. So these are the data type which is available. 2 simply means that I'm talking about a 16-bit. 4 simply means that I'm talking about 32-bit. And 8 simply means that I'm talking about a 64-bit. So this is how you will be able to convert, or you will be able to get a different kind of a integer data type itself with respect to a bit, or with respect to a big Indian or little Indian notation. Now, so in my life, I have never used this particular notation while doing a data processing. But if you are going to develop some kind of algorithm, or maybe if you are going to write a code which just depends upon the 16-bit computation, or maybe a 64-bit computation, or maybe a 34-bit computation, at that point of a time, this kind of a concept may be handy. But as far as this data processing is concerned, or model building is concerned into a image with respect to image, or maybe like a textual data, or maybe with respect to a tabular data frame, so you are not going to encounter these things frequently. So it's completely fine. So just for the information, so I have shown you these particular things. Now let's suppose I wanted to build a matrix data type. So matrix is basically a data type which is available inside a NumPy package. I can try to create it. It's very easy. So what I can do is I can try to call np.mat. So you will be able to find out that mat is something which is available inside a NumPy package. What I can do is I can try to do the selection operation, and then I can try to pass maybe a list over here. Let's see what happens. So if I'm going to pass a very simple list, a similar kind of a list which I have passed inside my array, now you will be able to find out that my data type is not array. My data type is basically a matrices. So matrix is a subset or subclass of a array. So array is a superclass inside NumPy, and matrix is a subclass of that particular a child class of a array. If I'm going to check a type of this, so for sure it is going to give me a matrix data type as expected. So numpy dot matrices, so it's a data type of the type like matrices. You will be able to get it. So this is completely fine. Now what I will try to do is, so I will try to perform some kind of a operation. So there is something called as a numpy dot as any array, as any array. Now, so what is the meaning of this as any array and what it does basically? So as we have already seen in our previous example, that if I'm going to type numpy dot ay, and if I'm going to pass maybe a list over here, it will give me array. If I'm going to call, so let's suppose I have created a matrices over here, and if I'm going to store this matrix as m inside a variable m, so this is my matrix data type as of now. Now if I'm going to pass this m and inside np dot array array, and then if I'm going to pass m over here, so if I'm going to pass a list element, it is going to convert into array. If I'm going to pass a matrix element, it is going to convert an element into array. So in both the cases, in case of a list or in case of a matrices, in both the cases, it is able to convert my data in a form of array. That is completely fine. But what this any array will do? So let's try to understand this thing. That's the reason. So I have given you these two examples. So here, what this will try to do is, so let's suppose if I'm going to pass, let's suppose if I'm going to pass a list over here. So list wise 5, 6, 7, 78. So it is able to convert into an array. That is completely fine. But what if I'm going to pass my matrix inside this one, np dot as any array. So as any array, and what is my matrix element m. So what if I'm going to pass my matrices over here, so you will be able to find out that no, this time it is not trying to convert, this time it is not trying to convert into an array. Last time in this case and in this case, I was trying to pass a list, convert it into array. I was trying to pass a matrices, convert it into array. But this time when I'm trying to pass a list, yes, it is able to convert these things into array. But when I'm trying to pass a matrices in as any array, it is not trying to convert it. So what is the definition of this as any array? Definition of as any array says that if my data set is available in some form, if my data set is available in some form of the array, I will not try to convert it. If my data set is available, if my data set will not be available in some form of a numpy array, so then only I will try to do a conversion. So as we all know that list is not an element which is like a array. List is not an array like an element. List is something which exists inside a Python code. So that's the reason. So it is trying to convert into array. But like I told you, matrix is nothing but it's a subclass of a array itself. So matrix is array actually. Matrix is a type of the array, or matrix is an instance of array. Instance means object of array, I would say. So matrix is already an instance of array. So in that case, it will not try to do a conversion. That this is what as any array is trying to do. For sure, if you have to convert something into array, you can try to call numpy.array or numpy.asArray. These are the two functions which is available. But if I don't want to convert some element which is already in some form of a array, so in that case, I can try to use as any array. So only it will try to do a conversion only if my data set is not available in any form of a array. A simple logic, a simple concept over here. Now again, don't try to remember any of this function which I'm trying to talk about. Forget about everything. Don't remember anything. Just try to practice it, and with practice you will be able to learn many more things, I would say. Now next thing which I'm going to talk about is a deep copy and a shallow copy. What is the meaning of a deep copy and what is the meaning of a shallow copy? Now, this deep copy and shallow copy concept is available in almost every programming languages. So let's try to understand it, that what I'm trying to prove over here and how I'm trying to perform a deep copy operation and a shallow copy operation. So let's suppose what I will do is I will try to create a variable called as a. A is nothing but so numpy array array, and then inside that, so I can try to pass maybe a 4 comma 5 comma 6 comma 7 comma 8. It's completely fine. And then what I will do is I can try to create a variable b, and b is equal to 8. It's completely fine. Now, so then what I will do is I will try to access b. You will be able to find out that I have created a variable a, and inside a variable a I have these elements. I'm trying to perform a reassignment operation, means b is equal to a, means whatever element we have inside a, so we will be having a same element. What happens inside a memory? So whenever I'm going to create like a variable a, so it is going to take one place, and then here it is trying to refer this like it is going to refer to this variable, and then inside that it is going to call 4 comma 5 comma 6 comma 7 comma 8, as simple as that. Now whenever I'm trying to perform this assignment operation, so in that case this b will always refer to the same location. So by a and b, by doing this operation, is trying to refer to the same location. So whenever I'm trying to call this b, it's completely fine. I'm able to get a same element. Whatever element I had inside a, I'm able to get a same kind of a element over here. Now, what is the meaning of this deep copy and shallow copy? Let's try to understand. Let's suppose if I'm trying to access b of 0, b of 0, so b of 0 is nothing but the 0th element. It's completely fine. Now if I'll try to modify an element which is available at 0th position, so maybe instead of using 4, I wanted to use this number on instead of using a 4 on a 0th location. So this assignment operation is completely fine. I'm able to assign a new element on a 0th indexes. That is completely fine. Now if I'll go and if I'll print this b, yes, this is a element changes which I have done. This is the data manipulation which I have done. If I'm going to call a, so with respect to a, I have not done a changes, but as b and a both is referring to a same location, because I have done b is equal to a operation. So in this case, it will try to change a as well. So it will change b as well as it will try to change a. So whenever whatever modification you will do in a, it will be reflected in b, and whenever you will try to do some kind of a changes into b, it will be reflected into a, because both is trying to point to the same location. What if I don't want to do it? What if I'm looking for some kind of a element where initially element will be same, but whenever I'm trying to make a changes into one element, it should not make a changes into other element. In this case, both is referred to the same location. So if I'm going to change in one variable, it is going to reflect a same changes into other variable, because location is same, like it is trying to point to the same location. Now what I will do is I will try to create another variable called as c, and inside a c I can try to call numpy, I would say dot copy, and here I will try to pass a. It's completely fine. Now what will happen in this particular case? So here when I'm going to create a variable c, so it's completely fine. It will try to create a reference variable c. Now what is a value which I'm trying to assign? So I'm trying to assign a value which is available inside a. As of now, this is the value which is available inside a after modification for sure. So here np.copy. So what this copy command will do? So it will not try to point out to the same location. It will try to reserve a new location for you. It will try to point, means this variable is going to point to this new location, and then it will try to copy this data from here to here. So here I will be having a data. Now what will happen? So now suppose if I'm going to make some changes, so c is equal to this data and a is equal to this data, means in c and in a, in both the location I have a similar kind of a data. In both the location I have exactly same data set which is available. So okay, So here you will be able to find out that in C and in A, I have exactly same data because I have done copy basically. So copy or data from A to C. This is what I have done. Now, if I'll try to modify something in C, suppose if I'm trying to modify something in C, so C of 0 is 535. Maybe I can try to assign some different like a number over here. And then if I'm going to print C, so it has changed C for sure. So previously it was 535. Now it's a 343. Simple. So it has made the changes. There is no if and but with respect to that. If I'll try to print A now, it has not done a changes with respect to A, or vice versa. If I'm going to make some changes into A, you will be, so A of 0 maybe this kind of a number, and if I'm going to print A, this is something that it has done. But if I'll try to print C, it is not going to reflect a same changes into C. So here, why it is not reflecting the changes? Because location where my C is trying to point and the location where my A is trying to point is completely different. So when I have done copy operation, numpy.copy, so I have copied this entire data from this location. So whatever I'm going to perform over here will be independent of the operation which I'm going to perform in this particular place. So guys, this is what happens. So basically the approach which I have used in this one, the approach which I have used over here to assign a value. So this particular approach is called as a deep copy, and this particular approach is called as a swallow copy. This is something, and this is how you are supposed to understand it. So this is called as a swallow copy, and this is called as a deep copy. In case of a deep copy, if you are going to make a changes in one variable, it will not reflect a changes into other variable. But in case of a swallow copy, so well, if you are going to change one variable, it will try to reflect a same kind of a changes into other variables as well. So this is what you should know, I would say. So it's completely fine. Now moving ahead, and let's try to understand that how and what and all different kind of a function which is available inside a NumPy. So let's try to understand it. So I can try to call basically a function called as numpy dot from function. So from function I can try to call now. So what this from function does, let's try to understand it. So I can try to call like I can try to create a lambda over here. So lambda is going to take maybe x and y, and then it is going to perform, I would say, like x is equal to y operation, and then I can try to give maybe a dimension. So 3 comma maybe a 4 I can try to give. If I'm going to execute it, this is what I will be able to get. So in NumPy, every time, whenever you are going to get some kind of a output, every time you will be able to get some kind of a array or some kind of a matrices, whatever function you are going to use. That is a speciality of a NumPy that you will be able to find out. Now, so here what I have done. So here I'm trying to use NumPy dot from function. Now what is trying to do? So from a function, it will try to generate some kind of a array. So far, so forth, I have been using like a np dot array, or maybe np dot as array, or np dot as any array, or np dot mat. So these are the functions that I have been using so far, so forth. It's completely fine. Now, if I'm going to use this from function kind of a thing, so in that case, it will try to generate this particular array based on the function which I have given over here. Now, in this particular place, you can try to write your external function. You can try to call your external function, or you can try to write your lambda function, as we have already discussed about a lambda function in our previous classes. So when I was talking about a map, I was talking about a reduce, or I was talking about like many things in other places. So I talked about, or I have discussed about a lambda function for sure. So it's completely fine, not an issue. So here, what this lambda function is trying to do. So here you will be able to find out that this lambda function is trying to take two arguments, and it is trying to perform x is equal to y. I have given dimension is equal to 3 cross 4. So when I'm trying to give a 3 cross 4, it means I'm trying to create an array of 3 row I would say, and 4 column. This is what I'm trying to do. So this is a dimension which I have given 3 cross 4, 3 row, 4 column I have given. Now I'm trying to write like xy. So it will try to take two variable, two argument. Xy is equal to x is equal to y. And then based on this function and in this array, so it will try to give you a final matrices or final array. Let's try to understand this part. So here what it will try to do is it will try to match a column and a row and column value. So 0 is equal to 0. Here we are trying to do x is equal to y. So x is nothing but this one, y is nothing but this one. So 0 is equal to 0. Yes, it's true. 0 is equal to 1. False. 0 is equal to 2. False. 0 is equal to 3. False. 1 is equal to 0. False. 1 is equal to 1. True. 1 is equal to 2. False, 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 true, false. This is the same output you will be able to find out over here. So it is trying to give you, or it is trying to generate a data based on this function. So function that you have written on top of some kind of a dimension, because like I told you, so numpy.array always try to give you some kind of a array. Except array, it is not going to give you any other things. So fine guys, this is what like I'm able to get in this particular place. So I'm able to get basically data out of this particular function. So it's completely fine. Now what I will do is I will try to write maybe some other kind of a function as well. So I can try to copy the same thing, and I can try to write maybe x plus y. Now let's see what happens in case of a x plus y. So here if I'm going to write x plus y, logic is not going to change at all. So what it will do is, so it is going to take 0 1 2 because it's the 3 cross 4, so 3 row, and 0 1 2 3, so 4 column. Now I have written x plus y. X plus y if I have written, so 0 plus 0 0, 0 plus 1 1, 0 plus 2 2 and 3, 1 plus 0 1, 1 plus 1 2, 1 plus 2 is equal to 3, 1 plus 3 is equal to 4, 2 plus 0 2, 2 plus 1 3, 2 plus 2 4, 2 plus 3 5. It's the exact same data you will be able to get even over here. This is how it is going to give you a data based on the row and column condition that you have written. So here I have written like a plus operation, and last time I have written basically a Boolean operation. So true and false kind of a operations I have written in a last cases. So it's completely fine guys. Again, this is like a how I will be able to perform our data manipulations over here. Not an issue. Now what I can do is I can write maybe like any kind of things over here, like a minus, plus, division, subtraction, maybe x minus y into, let's suppose, 6. I can write whatever I want, so there won't be any issue, and based on that I will end up generating a array. So this is just a function by which you will be able to generate a array based on your logic, the logic that you are going to write. Now the next thing which I'm going to perform, or the next thing which I'm going to do, so what I can try to do is, suppose if I have a string, so I have used np.from function. Now np.from string I can try to use, and then I can try to pass maybe a string over here. So maybe I can try to pass like 1 space 3 space 5, something like that. If I'm going to pass, so this is basically a string. I've enclosed my data within a string. You will be able to find out. And then what I can do is, separator wise I can try to write like separator is equal to a space. If I'm going to execute it, so it will try to take this string, it will try to take this string, and then it will try to separate my data based on the space, because by default separator will be equal to space. So even if I'm not going to mention these things, I think it will work fine. Now here, so I have used basically string, my separator is a comma, so I'm supposed to mention separator is equal to comma. If I'm not going to mention, it will not be able to separate it. And as you can see, so yes, after separation, so I'm able to get a data. Maybe I can try to pass some kind of a SUDH and comma KUMAR, something like that. And in this case, what you will be able to get is nothing. It's a blank data that you will be able to get. Let's try to understand that whether I will be able to change a data type or not. So data dtype is equal to str. So if I'm going to mention something like that, So here you will be able to find out that it is not able to understand this particular thing. It is trying to give me an issue that zero valued item size. So whatever item that you are trying to mention over here, no, it's not able to like understand this item. If I'm going to give 6,7, again, it is not able to understand. Suppose if I'm going to give integer, now it is able to understand basically. So data type wise, I'm trying to pass an integer and then I'm trying to pass a separator. Data wise, I'm trying to pass a string. So it will try to read this string, it will try to separate it, and finally it is going to give you integer of a array over here. So likewise, you can try to perform like any kind of a permutation combination, and you will be able to get a similar kind of a data. Now, the next thing which I'm going to perform over here is, so let's suppose if I'm going to create a basic array, I will try to create. So before that, I will try to create a nested list maybe. So 3 comma 4 comma 5, and then maybe I can try to use like 6 comma 7 comma 8 comma 8, and dimension should be same. Otherwise, it is going to give you an object of a list 6 comma 7 comma 9, and I can try to close it. Now np dot a double ray array a. So I'm trying to convert this data, the data that I had over here, into this particular form, into a form of array. So I'm able to convert my list into an array, not an issue. So I will try to store these things inside a variable called as n, should be np. So yeah, so I'm trying to convert these things into a array. Now what I will do is I will try to show you a basic operations over here. So if I wanted to know that what is a dimension of this particular array. So as we can observe that dimension of this particular array is nothing but it's a 2-dimension, but still I wanted to print it. So n dot, I can try to type ndim. So I will be able to get that dimension of this array is equal to 2. Now, so at the time of creation of an array, so I have like a ndim parameter. Now, if I'm going to override this parameter, and if I'm going to mention dimension is equal to 10, what happens in this case? So for sure, it is going to attach a 10 square bracket in front of my data. So as you can see, and then if I'm going to check, it's a 10 dimension, but by default, so by default, the dimension of this array is equal to, I would say, 2. And this information is very much important. This is a small information, it's completely fine, but when we try to do a mathematical computation, a mathematical calculation in between a matrices, so you are going to get an issue, because if dimension of the data is not same, so you are going to face many kind of problem, and then you will have to go for the reshaping of the data. But again, in what kind of a reshape, what kind of a reshape you will be able to do, you will be able to get all the information by following this approach itself. So it's completely fine. I'm able to get a dimension. There is something called as a size. So n dot size, if I'm going to compute, size means what? Size means a total number of an element inside this particular array or a matrices. Whatever is going to work on array, same thing will work into a matrices as well. So size always talk about a number of the element. Now I can try to type maybe a shape. Shape is nothing but a row into column. So as you can see, I have a 3 row and 3 column inside my data. So n by n or n cross m. So whatever is a size of your matrices, number of rows and number of columns that you have inside your matrices. So shape is going to give you that one. So it is going to tell me that, okay, fine. So like a shape of this particular array is nothing but it's a 3 cross 3, and size always give you like a number of element. Dimension always try to give you that what is a dimension, whether my array is a 1D or maybe a 2D or maybe a 0 dimension. So maybe I can try to create this array. So m is equal to np dot a double ray array, and then inside that maybe I can try to pass 5 comma 6 comma 7 over here, and m dot ndim. If I'm going to check, it's a 1-dimensional array, I would say. So suppose if I'm going to remove these things, I'm going to put just a bracket. It's a 1-dimensional array. So by default, if your array is even blank, so in that case, it will be a 1-dimensional array that you will be able to get. So 1D, 2D, 3D, 4D, this kind of array that you will be able to get. Now, so there is another thing which you should know. So suppose if I wanted to know that what is a data type of an array, because data type of the entire array will be same. Like we have already seen that even if a single data which is available inside your array is, is in a float, it will try to convert, it will try to upcast every data set which is available inside the array. So D type, and you will be able to find out that the entire data which I have inside my array is having 32. Now, if I wanted to override it, I can try to override it. Maybe I can try to keep my all the element as a 16-bit, or maybe as a 64-bit, or maybe as a 64-bit, or maybe as a 16-bit. So it's completely fine. We talked about like a I2, we talked about I4, we talked about I8. So that is a way. If you're going to define data type is equal to I2 or I8 or maybe I4, so in that way you will end up converting your data into a 16-bit, 32-bit or 64-bit. But by default, yes, this is what you will be able to receive. So fine guys, these are the 4 functions that you should remember. So that will help you out to check your array, and accordingly you can try to go for the modification. Next thing which I will be talking about is called as a arrange function. So I think we talked about arrange function. So range, this is a function that we have discussed in a very beginning. And if I'm going to pass 5, so we all know that it is going to generate a data in between 0 to 5, excluding 5, excluding upper boundary. Now, let's suppose if I'm going to give 5 dot, means 5 as a floating point number. So in this case, it is going to give me an issue. It is telling me that no, I can't accept floating point number. I only take integer. So even as an initial point, even as a final point, if I'm going to give, or even as a step size, if I'm going to give maybe like a floating point, it is going to give me a similar kind of a issue. So range function is a function which always accepts a integer. It is not going to accept anything else except integer at any point of a time. This is how I would say entire range function is been designed. So it's completely fine, guys. So you will be able to use only an integer in this particular case. You will not be able to use anything else except a integer. Now what I should do? So now if I have to like take maybe like a floating point, and based on that if I have to generate a data, so in that case I will not look for the range function. What I can do is I can try to call numpy dot arange function. So arange is something which is available inside a numpy. Inside that I can try to pass maybe 0.5. It's completely fine. I can try to like get a data. I can try to like keep a upper boundary as a 9.87. Let's suppose this is the upper boundary. It is not going to complain me. It's completely fine. Maybe I can try to give initial point as 1 2.5 and 2.5 as an initial point, and then this is a final point, and the size of the steps are nothing but 0.5. So 0.5 if I'm going to give, not an issue, it's completely fine. So it will be able to accept a floating point number as an initial point, as a final point, and as a step size, and it will be able to give you a data set. So this is something that you will be able to experience with respect to a arrange function. So arrange function, I would say, always works with the integer as well as it is going to work with the floating point number. But if I'll talk about just a range function, so range function is only going to work with respect to a integer. It is never going to work with the floating point number. So I think we are good with these operations that we have done. And again, once you will be able to get a data with the help of our arrange function, so whatever data slicing operations or indexing operations that we have discussed, so same data slicing operations, similar kind of a data indexing operations, you will be able to achieve even with respect to this arrange function. Exactly same thing. If you have to do some kind of a reverse, maybe colon minus one or something like that, you will be able to do, and you will be able to reverse your data. You will be able to like slice your data set. So fine, guys, this is what I have to discuss with you. Now the next function that I can talk about is called as a numpy dot, and again remember that it is always going to give you a array. Now, if I have to convert this array into a list, I can do that as well. So maybe I can try to store these things inside n, and then I can try to call a list function inside that. I can try to pass n as an array. I will be able to get a list. This is the list, but it is going to return you a array. So inside a NumPy package, whatever you are going to get, you will be able to get each and everything just as an array. Nothing else you will be able to get. So it's completely fine. Fine, guys. Let's start discussing this thing. So, fine. I was talking about a arrange function. Now, what I can do is I can talk about a NumPy dot line space function. Like any, okay, line space function. Okay. Now what will happen in this case? So line space is another function which you can use to generate a data. So let's try to understand that how you will be able to generate a data with the help of a line space function. So you can try to give maybe a initial point, you can try to give maybe a final point, and then in this case, this is not same as a range function or arrange function. Range and arrange both are same. The only difference is range is a part of a Python core, arrange is a part of a NumPy. And the second difference is range can only consider integer, whereas arrange can consider floating point as well as integer. Now here, there is a function called as line space. Now what this line space is going to do? So suppose if I have given initial point is equal to 3, final point is equal to 7, and then I have given 20. So what it will try to do is, so it will try to generate a 20 number of the data. Last time in case of a range function, it was basically a step size. Means here in this particular case, it was a step size. Means it will start from here 2.5 plus a step size 3 plus a step size 3.5 and so on. But here, this is not a step size. This is basically a number of the element that you are looking for in between these scale. So in between 3 to 7, it will try to find out 20 number. I can say that in between any number, in between even 0 to 1, you can generate a billion number. You can generate infinite numbers over here. That is possible. That is possible, I would say. So it is trying to generate a number. You will be able to find out that starting from 3 ending till 7, and the total number which it has generated is equal to 20. If I wanted to generate maybe a 200 number, I can generate a 200 number in between 3 to 7 itself, as you can see. So if I have to generate a numbers in between certain scale, in that case I can try to use a line space and it is going to generate that many number for me. It's so very basic concept. And again, if I'm going to give maybe like a floating point number over here, it is going to work. Maybe if I'm going to give maybe 2.90, it is going to work with some warning. It's completely fine. There is no meaning of giving a step size equal to this one, but always try to like upcast it. So this is what you will be able to find out, guys. So in case of a line space, you can try to generate any number in between any of the number that you are going to give, and yes, for sure it is going to work for you. Now if you will look into the parameter of this line space, so parameter wise it takes like a starting point, end point, and number of the element that you are looking for. Suppose if I'm not giving this number, so even in this case it will generate some number. That number is equal to 50. So if you are not going to give a third argument, so in that case, it will try to give you a 50 number as per the mentioned argument. Now, so you can try to mention endpoint is equal to false. Let's suppose if I'm going to mention endpoint is equal to, by default, it will be true. So false if I'm going to mention. Now what will happen? Endpoint wise, I have mentioned 7.9. Let's suppose. So suppose if I'm not going to give endpoint, or let's suppose endpoint is equal to true. So in this case, it will try to include a final point as well, means upper boundary as well. So here you will be able to find out that 7.9 in my upper boundary. Yes, it is including it. But if I'm going to make these things as a false, you will be able to find out that no, it is not going to include my final boundary point, just like a range and a range function. So this is what a kind of things that you will be able to get out of this one. So it's completely fine, guys. So endpoint. Now a ret step. So ret step is equal to, by default it's equal to false. Now if I'm going to make these things as a true, what is the meaning of that? So whenever you are trying to, whenever basically like here, if I'm going to write like 5, it means that I'm trying to generate 5 element. So this 5 element in between these to this range. This is the meaning of this. So I'm trying to generate basically 5 element, 1, 2, 3, 4, 5. 5 element I'm trying to generate in between these to this scale. So starting from a 3 to a 7.9 scale, I'm trying to generate. Now, whenever it will try to generate 5 data, so it will equally divide this entire region into 5 space. Equally, it will divide. Now, by default, it is not going to give you that after, because if I'm trying to generate maybe a data set, let's suppose like if I'm trying to generate a 5 data in between 1 to 10. So 5 data if I'm trying to generate. So first data could be 1, then 2, then 4, and then 6, and then 8. This is something which I can write. So if I'm trying to generate like a 5 data excluding the upper bound, so this is how it will be able to do it. So everywhere it is trying to take some kind of a constant step. So if you are going to make this ret step is equal to true, so it will try to tell you that okay, what is the difference between this and this and this. So difference between this and this is this step. Difference between this and this is this step. So this is what it is going to do. By default, it will be equal to false. Now there is another argument that you will be able to get over here. So another argument. So num we have discussed. Another endpoint we have discussed. Data type. So data type wise, you can try to mention anything. Suppose by default it's given as an axis is equal to 0. Axis 0 means row. Suppose if I'm going to mention axis 1 over here. So here you will be able to find out that based on the, let's suppose if I have given this one, yeah, it takes axis 0 by default and there is no other parameter which is given, yeah, axis 0. So if I have a multi-dimensional array, so in that case, yes, it is going to give me axis 0, axis 2, but I just have a linear array. So in that case, there is no meaning of getting axis 1 because I don't have any kind of a column, I just have a row over here. Now, the next thing that we are going to talk about is, so how we can create different kind of arrays and how I will be able to perform a reshape operation, because reshape operation is very much important. Reshape operation is always important, and as a data scientist, you are going to use this reshape operation and data generation or random data generation operation almost on a daily basis. So suppose if I'm going to give np.zero, np.zeros. So zeros if I'm going to give, and then what I can try to do is, so I can try to give maybe a 5 over here. So it is going to generate a data with all the data with zeros, I would say. So again, I can try to give maybe a dimension over here. So maybe I can try to write over here. So 5 cross 6. In this case, it is going to generate 5 row, 6 column. All the element it is going to fill by this number of data. Let's suppose if I'm going to give maybe a 2 cross 5 cross 6, it's a 3D data. So here you will be able to find out that I have created a 3D data over here. So 2. So we have basically like a 2 array. 2 array we have of size 5 cross 6. So this is having a 5 cross 6 size and this is having a 5 cross 6 size. This is how you are supposed to understand, or in a real time. So you can try to understand in this way. So we have a data, one data, and we have another data just behind of this data. So if I'll talk about the axis, so axis wise, suppose we have a x axis, we have a y axis, and we have a z axis. So let's suppose if I created an array over here. So this array is nothing but it's a 2D array. I have a x axis and I have a y axis, means I have a row, I have a column. But if I'm going to place something over here, just try to visualize it, just like pages which is available inside your books. So if you will try to start folding your pages, So one by one, one by one, one by one. So one after another in parallel, you will be able to get other pages in a similar way. So if you will try to visualize these things, this is how you can visualize. We have one array and behind that we have another array in depth. So height, width, and length you can consider, or maybe x-axis, y-axis, or z-axis you can try to consider. So we have one array behind another array. So how many array we have? We have actually two array. So this is one array, I would say. This is one of the array that I have. And the second array that we have is nothing but this one. Second array that we have is nothing but this one, just behind this. So I have, in total, I have one array is this one, and the another array is this one. One after another. So two. What is the size of one array? So size of one array is 5 cross 6. So size of the array which is available behind this array is also 5 cross 6. These things are important when you will try to talk about image processing. This things is very much important, I would say, whenever we talk about image processing, because when you will try to understand a convolution neural network, so you will be able to find out that it try to follows a same approach. So this is how you can understand a multi-dimensional array over here. I can try to create maybe a 4-dimension array as well. So here maybe I can try to mention like two over here, and this is nothing but a 4-dimension array. It's completely fine. It's a 4-dimension array, but visualization wise, you will not be able to visualize it for sure. There is no 4D which is available in which we can visualize as of now. Just till 3D, I will be able to visualize it even over here or even inside your like visualization tool by using a Matplotlib, Seaborn, or maybe a Cufflinks. This is how I will be able to visualize it. So it's completely fine, guys. I'm able to create all the array with a zeros. There is something called as a np.ones, I would say, and it's same as I would say like zeros. Instead of giving a zero, it try to give you just a, so it try to give you, I would say, it try to give you one. So like a 3-row and 4-column, it is trying to give it to you. So we have like a 3-row and we have a 4-column over here. This is the kind of array which it has created. I can try to mention 2 cross 3 cross 4. So it's completely fine. So two array we have over here of size 3 cross 4. This is how you are supposed to understand. So one array after another array. So in a Z coordinate, in a Z axis, I have another array in this particular place. So I can try to generate like a array with ones, array with zeros. There is no such array which is possible with twos. So there is no two which is available. I can maybe try to like create it. Maybe I can try to perform this operation. So twos and for threes, I can create it just by performing this kind of a broadcasting operation. Now the another thing that I will be talking about is, so if I'm going to call empty, so if I'm going to pass maybe 4 cross 5 over here, I will be able to get some random number in case of an empty. Now, if I'm going to print this empty of maybe a 0 of a 0, I just wanted to show you like what is the exact element which is available over here. You will be able to get 3. Now, if I'm going to execute, yeah, it's completely fine. So in your case, when you will try to execute a same thing, so sometime you will end up getting, maybe 3, 4, 5, 6, or sometime you will be end up getting a very small number, I would say. So, or sometime you will be able to get maybe a zeros. Here you will be able to find out that I'm able to get a very small number, e to the power minus 311, which is a very, very small number, which I am able to get. So empty is nothing but it just try to give you, or it just try to create some kind of a random element, and it will try to give almost element close to 0 most of the time. I'm not saying that all the time, but most of the time it will try to give you element close to 0. In some of your system you will end up getting 0 as well. That is called as a empty array, I would say. Empty means a value which is close to a 0. Now the next thing which I will be talking about is called as a np.eye. So I is nothing but it's a identity matrix. I think in a childhood we talked about in a 8th 9th standard. So we generally talk about matrices in which we will be having a 1 1 1 in a diagonal element as a diagonal element. So if I have to like, I wanted to get like a 1 1 1, and if I'm trying to do a matrix multiplication, it should give me only 1. That kind of a matrix is called as a identity matrix. And if you are going to create identity matrix will always be a square matrix. A square matrix means number of row and number of columns should always be same. That is called as a square matrix. So identity matrix will be like for sure it will be a square matrices, and whenever you're trying to perform a matrix multiplication or matrix computation, so it is going to give you 1. So it is possible to create identity matrix of any dimension. So I can try to give 4. I just have to give like a one element, one input over here, because row and column will be same, because identity matrix will be a square matrices. So you will be able to find out that all the diagonal elements are 1. Now, if you will try to perform a calculation on a determinant of this particular matrices, you will be able to get 1 as a final outcome. It's completely fine. So this is where, or this is how you will be able to create, I would say, like identity matrices. Again, these things are very much important when it comes to a data or matrix multiplication, because image processing or signal processing or like a training a model is nothing but it's a matrix multiplication. If you are going to use like a neural network, it's nothing but it's just a matrix multiplication in itself with a derivatives. So it's completely fine. This is what you will be able to get. Now the another thing that I can talk about is called as a log space. So let's try to talk about that. What is a meaning of a log space? What is a meaning of a line space, and how these things is actually going to work? So fine guys, I think I talked about line space now this time. So let's try to understand that how I will be able to get a logarithmic of the data set. Again, so it's nothing new or nothing fancy, I would say. So it's almost same as a line space that we have discussed. So I can try to call np dot log space. So log space. Now what I can do is I can try to maybe give a range in between 5.6 to 7.8, and maybe I wanted to generate 6 element. So what will happen is it is trying to generate a 6 element, and it is not going to give you an element. It is going to give you basically a logarithmic of all the element which it had generated so far, so forth. So this is what this particular operation is going to give you guys. So it's completely fine. A log space is almost close to a line space. The only thing is line space just give me an element directly, whereas log space is going to give you a logarithmic. Again, you have a control. So if you wanted to change maybe like a base of the log, you will be able to change it. By default, base will be equal to 10. Let's suppose I wanted to perform all the calculation with respect to base is equal to 2. I'm assuming that all of you are aware about a base. So on base 2, this is the logarithmic of each and every data it is going to generate. It's completely fine. Now what I can do is, so there is a function, I would say there is a function called as arrange function. So let's try to understand that what is a meaning of a arrange function. And yeah, arrange function we have already discussed. So let's try to understand that how we can try to generate a random number. So I can try to call maybe like numpy. Again, this function, these are the few of the function which we are going to use on a daily basis. So I can try to call random random, and then after doing this random, so maybe I can try to call rand. So if I'm going to call numpy dot random dot rand, and then if I'm going to pass a dimension, so it is going to create an array. It is going to create an array of size 4 cross 5, 4 row, 5 column, and it is going to give you a random data. It is going to give you a random data. So every time whenever I'm going to execute it, it is going to give me a random data. There is a procedure, there is a way by which I will be able to get a same data, and you will be able to get a same data every time. Even if I'm going to call a random, there is something called as a seek operation. So I will talk about that. I will talk about that operation, but yeah, when time will come. So here I'm trying to generate basically data of 4 cross 5. Let's suppose 4 cross 5 means I have 20 data. Let's suppose if I wanted to store this data inside a variable m, it's completely fine. I can store it. And then I'm trying to generate m over here. Now let's suppose if I wanted to reshape, or I wanted to change a dimension of this data. So from 2D to 3D, or maybe to 1D, if I wanted to generate, or maybe I wanted to reshape this data into some other shape. So how I will be able to do it? I have in total 20 element. So I can try to call n dot reshape over here, and then reshape wise, what I can do is I have n total 20 element. 4 cross 5 is equal to 20. So I have to give over here a dimension which will be like multiplicate. So if I'm going to multiply these two arguments, it should always give me a 20. Otherwise, it is going to give you an issue. So maybe I can try to convert my data into 10 cross 2. It's completely fine. So 10 row, 2 column. It's the same data. It's the exact same data. I'm just trying to perform what? Reshaping operation. Maybe I can try to perform into a 20 cross 1, 20 cross 1. So it's completely fine. I'm able to get that. Not an issue. Now let's suppose if I wanted to convert this data into 5 cross 4, 5 cross 4, it's completely fine. It is able to convert this data. So previous one was 4 cross 5. Now it's a 5 cross 4. So you will be able to reshape your data set in any dimension to any dimension. There won't be any restriction and there won't be any difficulties. You will be able to find out. And reshaping of the data is very much important. Again, these are like a few of the function that you are going to use very frequently as a data scientist. Now, so m dot reshape, and yes, I'm able to like perform this reshaping operation, 5 row and then 4 columns, in which I'm able to reshape my data. Let's suppose I wanted to reshape a data, and I have given 10 over here. So maybe I can try to give any kind of a number in this particular place. It is trying to take 10 cross 2. I can give any number over here. Doesn't matter at all. So in general, you will be able to find out that people used to give -1. Now, it's not like -1 you should use all the time. You can use any negative number. You can try this out. You can use any negative number. It's completely fine. Now, what this negative number does? So if you have already defined one dimension, if you want your system to understand other dimension, it will be able to understand. It will think that, okay, fine. So 1 is 10, which has been given, and total number of data is equal to 20. So 10 cross 20 is, so 10 cross 2 is equal to 20. So it will try to like understand -1 is equal to 20. So any negative number you can try to give over here, it will try to behave into a similar way. It is not going to change. You can try to write a minus like some data even over here. At one dimension at least you should provide. See, it has converted my entire data set into 2 cross 10. So as you can see, so I have like a 2 data set, and in every data set I have a 10 element basically. So this is how it will be able to perform transformations of the data into any shape to any shape. Now let's suppose if I'm going to give maybe a 10 cross 3, it is going to give you issue, saying that no, I'm not able to understand this particular shape that you have given. I just have a 20 elements. So whatever dimension that you are going to give it to me, that should be a multiplication of a like a, it should always give you a 20 number if you're going to multiply like a row and a column. So this is what you will be able to get over here, guys, in case of a reshape operation. Now, so I was talking about np.random.rand function. So what I will do is I will try to call some other function over here. So let's suppose if I'm trying to call rand n, and then if I'm going to call 5 cross 6, even in this case, you will be able to get a data. There is a very small differences you will be able to find out between a random and a rand n. So if I'll talk about a rand function over here, so you will be able to find out that it is going to give me always a uniform distribution. There is something called as a normal distribution. There is something called as a standard normal distribution. So in our statistics class, I'll talk about like basically those things. I think I will start a community edition of a statistics class as well, stats and probability, which has been required for the data scientist. So in that one, I will be talking about a bell-shaped curve. I will be talking about a normal distribution. I will be talking about the standard normal distribution. I will be talking about like how we try to calculate like a y-axis by using a normal distribution formula, 1 by root of 2 pi rho e to the power minus 1 by 2 into x minus mu by rho of square. So how I will be able to, I used to derive these things, and then I used to talk about like what is the significance of normally distributed data, what is the significance of standard normal distribution, how I will be able to convert normal distribution into standard normal distribution. Many things we used to talk about. What is the meaning of like when we say into a standard normal distribution mu is equal to 0, standard deviation is equal to 1. So everything I will be talking about not here but into a statistics class. Here you should understand that rand function always try to give you a uniform distribution. Means if you will try to find out a mu of this data, mean of this data, it will not be equal to 0 all the time. But at the same point of time, if you will try to find out a mu of this data that I've generated, so you will be able to find out, so mu will be close to I would say 0. Means average will close to a 0 for this particular data. If you will start increasing a data size, it will start tending towards a 0 in terms of a mean or in terms of a mu. So fine. So this always try to generate a standard normal distribution. Now, if you will look into the definition, standard normal distribution data, it try to generate, whereas like rand n function. So rand n generates a standard normal distribution data, rand n, and only rand function, if I'll talk about rand function try to generate a uniform distribution. So fine guys, again apart from that, so I have like numpy dot rand int int. I can try to give like 3,8 I can try to give, and then what I can do is I can try to write like a dimension 5 plus 6 over here. Now and numpy dot random dot. Okay, so here you will be able to find out that there is a function called as rand int. In case of a rand function, in case of a rand n function, so it always try to generate what? It always try to generate a floating point number. Suppose if I wanted to generate only a integer in between some certain ranges, I would say, so yes, I will be able to do that. So in between 3 to 8, it has generated 30 element. So again, there will be a repetition because it's just a 3. It will try to give you an integer in between 3 to 8, but it will try to give you an integer based on the dimension that you have given over here. So this is what guys you will be able to find out inside a randint. I think we talked about a reshape operation. So reshape is a basic operation that you should know at any point of a time. Again, in terms of indexing and slicing, suppose if I have an array, let's suppose if I'm going to store this array inside A. So A is nothing but this element that I have as an array. Now let's suppose if I wanted to access an element out of this particular array. So how I will be able to access element out of this particular array? So I can try to write maybe a 0, and if I'm going to write 0, I will be able to get a 0th row. That is completely fine. Maybe if I can try to write 0 to a 5, so let's see what will happen. So whenever I have written 0 to 5, or let's see, I'm going to write 0 to 2. So you will be able to find out that in case of a 0 to 2, so it is giving me a 0th row, it is giving me a first row, excluding second row. And I can try to write 0th of 2 over here. You will be able to find out that it is trying to do a slicing operations and it is trying to give me only these one. So means 0, 1, 0, 1. This is the meaning of this one. So if I have some data set, even if I have a 3D array, I will be able to extract the data. I just have to write another axis over here and it's completely fine. There won't be an issue. I will be able to get a data set very easily. So this is what happens guys, I would say in terms of a data slicing operation. Now whatever operations that we have discussed so far so forth, everything is applicable even over here. Everything bit by bit, everything is available even in this particular place. Now what I can do is, so maybe I have array A over here. Now I can try to write A greater than 5. So if I'm going to write A greater than 5, so whatever element and wherever data I have, so if it is greater than 5, it is going to give me true. Otherwise, it is going to give me false. So yes, 7 is greater than 5, so it is giving me true over here. Rest of the element will be equal to false. Now, if I'm going to pass this data inside an array itself, what will happen? It is going to give me only those data which is going to validate with this particular condition. So you can try to write any kind of a condition as well, and for sure you will be able to get a data based on your given condition. So it's completely fine. So I can just write a condition just like a pandas, and then I will be able to get a data very easily. Now let's suppose if I wanted to perform some kind of assignment operation, so a of maybe like a 0 of a 0, so I can try to perform assignment operation as well. So it's completely fine if I'm going to print a. As you can see, on a 0 of 0 location, it has replaced this particular element. So this proves that array is basically like a mutable element. Now, so let's suppose if I'm going to perform, or let's suppose if I'm going to create some kind of a array, m is equal to np array list of so this is my m. Now what I will do is I will try to get n. Now n is what? Okay, so I have basically like a 2 array over here. Now if I'm going to perform a m plus 1 operation, m plus n operation, so in this case what will happen? So it will try to perform this addition operation. It will try to perform this addition operation index wise. It is going to perform element like index wise element operations over here. Now if I'll talk about m minus n, so again, index wise, it will try to perform the operation. Let's suppose index of one element is different and other element is different. In this case, it is going to give you an issue saying that, okay, so I was expecting this and you have given me some other element. So make sure that whenever you're going to like perform this kind of operation, so your array dimension is always same. Now, if I'll talk about like into m into n, so again, this is not a matrix multiplication. This is basically a index wise operation, simple. So index to index, it will try to like perform this multiplication operation. So m cross n, so 67 into 3, 4 into 4, 5 into 5. So yes, so 7 into 3, 4 cross 4, 5 into 5, and so on. So this is basically a index wise operation it is trying to perform. Matrix multiplication is completely different. For example, let's suppose I have one matrix m1, or like I have an element called as a 0, 1, 2, 3. This is the element that I have. Then again, I have another matrices m2, let's suppose, and I'm trying to perform like 2, 3, 1, 8. This is the element that we have, m1 and m2. Now, if I'm looking for a matrix multiplication, what I should do in that case? I can try to multiply this with this. So I can multiply 0 into 2 plus 1 into 1. Then this with this I can try to, so this I will try to multiply with this particular element. So it's completely fine. So 0 into 2 and 1 into 1 I can try to multiply. As you can see that it's a 2 cross 2 element. It's a 2 cross 2 element. Then I can try to multiply this with this one. So 0 into 3 plus 1 into 8. Now, so I can try to multiply this with this one again. So 2 into 1 plus 3 into 2 into 2. So here 2 into 2 plus 3 into 1, and then 2 into 3 plus 3 into 8. Now, if you will try to solve it, so 0 into 2, 0, you will be able to get 1 over here. And then 3 into 0 is equal to 0. You will be able to get 8 over here. And then 2 into 2 is equal to 4, plus 3 is equal to 7. And then 3 cross 2 is equal to 6. And 8 into 3 is equal to 24. So it will be equal to 30. So this is a final matrix multiplication that you will be able to receive. Now let's try to do the same thing over here. So here I can try to write m1, and m1 is nothing but, so same element I'm going to take. So numpy dot array, and I'm going to take basically list of lists so that I will be able to convert it. So 0 comma 1, and then I can try to take maybe like 2 comma 3. This is m1. Now if I'll try to print m1, this is how it looks like: 0 comma 1, 2 comma 3, same element. Then if I have to calculate, or if I have to create maybe m2 over here, so m2 is nothing but, so numpy dot array array, and then inside that, so I can try to create maybe 2 3, so 2 comma 3, and 1 8. So I can try to like put, I would say, 1 comma 8. So it's completely fine. M2 is nothing but this one. Now I don't want to do m into, so m1 into m2. If I'm trying to do m1 into m2, so I'm able to get 0 3 2 24. But no, that is not an answer which I have received by doing my manual calculation. So what I can do is I can try to do m1 at the rate m2. Now you will be able to find out that whatever manual calculation which I have done, and whatever result which I'm able to secure over here, this result 18730, I'm able to get exactly a same result by doing a matrix multiplication. So into is not a symbol for a matrix multiplication. Into is a symbol for index wise multiplication. If you have to do a matrix multiplication, in that case you can try to use at the rate symbol, and in this way you will be able to get a matrix multiplication. I'm assuming that you all know the rule of a matrix multiplication. So suppose if I have like m cross n matrices and n cross p matrices, so this two things should be same. This one should be same. So if this one is same, then only you will be able to perform a matrix multiplication. Means a column of a first matrix and a row of a second matrices should always be same. If it is not same, you will not be able to perform a matrix multiplication. You can try this out, and the final matrix that you will be able to get is equal to m cross p. So I already had 2 cross 2 and 2 cross 2. So yes, 2 is equal to 2. That is completely fine. So finally I will be able to get a matrix of 2 cross 2. So like a 2 cross 2. So yes, I'm able to get a matrix of 2 cross 2 over here. So remember always guys, like how matrix multiplication happens and what is not called as a matrix multiplication. That is very much important for you. Now, so addition, subtraction, multiplication, division. Let's suppose I wanted to give a power. So M1 is a element which I have created now. So I wanted to give a power is equal to 2. So you will be able to find out that this is the original matrices. Now if I have done a power, double static means power. So it is going to give like a 0 into 0, 1 into 1. So 1 into 1 is equal to 1. 2 into 2 is equal to 4, 2 to the power 2. 3 to the power 2 is equal to 9. So yes, it's a 9. So this is what is the meaning of a power that you will be able to give. Power wise, you can try to give, or you can try to use a power function as well. It will do the same thing. So maybe you can try to call M1, and then you can try to give maybe a 2 over here. You will be able to get a same result. So both way it's completely fine. You can try to give a power wise, it can be root as well. There won't be any issue at all that you are going to face in any cases. Now so let's try to perform some kind of operation. So here I'm going to create let's suppose I'm going to create np dot zeros, so zeros, and I can give 5 comma 6, or maybe like 3 comma 4, let's suppose. So it's completely fine. I'm able to get a data, or like I'm able to get all the zeros as 3 comma 4. So like a 3 row and a 4 column, I'm able to get it. That is completely fine. This is what expectation is. Now if I'm going to perform like a m plus 1 or m plus 2, so it will try to add this element, or I can do a subtraction as well. I can do multiplication, division, or any kind of arithmetic operation. There won't be any issue. So I can try to perform this kind of operation. That won't be any kind of a issue that you are going to face. That is completely fine. But this is called as a element wise broadcasting operation. Means with respect to every element, so I'm trying to broadcast my data. Means I'm going to add 2 in every element. What if I'm looking for a row wise broadcasting operation, or if I'm looking for a column wise broadcasting operation. What I should do in that case, let's suppose so let's try to perform this operation. So I'm going to create m1 over here, or let's suppose n1 I'm going to create. N1 is nothing but so np dot array, and in a single row I have basically like a four element. So maybe I can try to give 1 comma 2 comma 3 comma 4, maybe 2. It's fine. If I'm going to execute it, so it should work fine. So bracket, and here it should be a bracket. So fine, here I have n1. Now what if, so I have n1 as this one and I have m as this. So this one is the element. Now what if I'm going to do m plus n1, what will happen in this case? Let's understand this. You will be able to find out that this time when I'm trying to provide a entire number of the data is equal to total number of data which I have inside a single row. So in a first row I have 1 3 4 2. It's completely fine. So I'm trying to provide this data. I'm trying to add these things with this one. So it is trying to perform a row-wise broadcasting operation. Last time, when I've just added one element, so it was trying to do element-wise broadcasting. This time, so when I'm trying to like add this plus this, so it is trying to do a row-wise broadcasting operations by default. Broadcasting means it is trying to perform the similar operations. So 1 3 4 2 1 3 4 2 1 3 4 2, it has added with respect to this one. Now what if I wanted to perform a column wise broadcasting, or what if I have like a more number of element over here? In this case, what will happen? There will be an issue. So if you are trying to do a broadcasting operation, so it will make sure that shape is always same. If shape is not same, for sure you will not be able to get outcome. So fine, shape is same. Now let's suppose, what if I wanted to do a broadcasting operation along with a row, along with the row, if I want to do a broadcasting operation. So is it possible? Because this is the this is like horizontal broadcasting operation. Suppose if I wanted to do a vertical broadcasting operations, in that case how I will be able to do it? So if I have to perform this kind of a operation, so maybe I can try to create a numpy dot array, and I can try to give maybe like 3 comma 4 comma 5. That's the dimension. It's a 3 data set is available in one single column or vertical like a way. So if I'm going to do this kind of operations, and let's suppose if I'm going to store these things into n2, so n2 is nothing but this one. If I'm going to do like m plus n2, it is going to give me an issue, because by default this is nothing but it's a horizontal array, or array along axis is equal to 0. So axis is equal to 0. Along with that, it always try to create an array. So what I should do in that case, maybe I can try to do a transpose operation. So I can try to call dot t now. So if I'm going to perform a transpose operation, so what you have to do is just try to perform a transpose operation, and by doing this transpose operation, you will be able to transpose a data, or you will be able to rotate a data. So make sure that you are going to take a two-dimensional data over here. So as you can see that it is able to perform a transpose operation, a vertical operation it is able to do. And now if I'm going to perform a broadcast operation, so 3 4 5 3 4 5 3 4 5 3 4 5 along with a vertical column, so it is able to add it, or it is able to broadcast it. So this is something called as a broadcasting, and this is how broadcasting is going to happen actually. So you will be able to do element-wise broadcasting. You will be able to do row-wise broadcasting, because many times you will try to face this kind of issue. Like I have to normalize my data, I have to standardize my data, or maybe I have to perform a similar kind of operation on a millions of arrays at a time, or millions of the data at a time. So these are the broadcasting operation which always it's a handy operation. So you will try to do it, and in that way you will be able to perform a data manipulation. So vertically, if you wanted to add something, you can add it. Horizontally, if you wanted to add something, yes, you will be able to add it. There won't be any kind of a issue that you are going to face. Now what I can do is I can try to maybe create an array, and np dot random dot rand, and I can try to give maybe a dimension of the array 4 comma 5. So it's completely fine. So it is able to generate a 4,5 random data. Then I can try to do maybe a reshape over here, RESHAPE, reshape, and 4,5. So I wanted to convert into a 10 cross 2. So now 10 row, 2 columns. So it has generated some other data, and then I'm trying to just reshape it. It's completely fine. Now what I will do is I will try to like take this as a M, and I can try to like generate another random data. This is like a M I have, and M is equal to this one. I can try to generate maybe M1. For sure it's a random data, so it is going to be different. M1 I have generated, M I have generated, so it's completely fine. Both data set is different. Now, so if I wanted to perform a square root operation for all the elements, what I can do is I can try to call numpy dot sqrt and M1. So in this case, it will try to perform, or it will try to give you a square root of every element which is available inside M1. This is what it does, square root. Now, so let's suppose if you have to calculate an exponent of every element, so exp, and you can try to mention M1 over here or any matrices. This is nothing but it's an exponent of the M1 data set that we have created. This is the exponent. So these are the function which is available. I'm just trying to talk about a function over here, nothing else. Maybe if you wanted to get a log of every data set, log, so log 10, log 2, whatever you want. So log of M1, yes, you will be able to get a log as well of every data set. Now let's suppose if you wanted to like you have M1 and you have M as well. If you have M as well over here, now let's suppose you wanted to perform a division operation and you wanted to print like you wanted to print, I would say, a remainder. So you can try to type M and M1 over here. You will be able to find out that it is giving me a remainder. F mode does what? So F mode always try to give a remainder. Let's suppose if I'm going to divide 10 by 3, what will be a remainder? Remainder will be equal to 1. If I'm going to divide 5 by 2, what will be the remainder? Remainder will be equal to 1. Or 7 by 5, if I'm going to divide, remainder will be equal to 2. So this is just going to give you a remainder. It will try to divide this by this and M by M1, and then whatever will be the remainder, it will try to give you a remainder, as simple as that. So this is how this mathematical function is going to work with respect to an array. And this is what I was supposed to discuss, I would say, guys, in today's class. So keep practicing, I would say, all those things in the next class. So I will talk about a visualization, so which is nothing but a matplotlib, couplings, seaborn, plotly. So I'm going to cover these libraries in terms of a visualization. You will be able to visualize your data set. I'll talk about how this visualization is different from a visualization that we used to do into a data analytics tool like a Power BI or Javelin or maybe Tableau or maybe a ClickView or something like that. So this is all about NumPy. Now in NumPy, there are thousands and thousands of functions which is available. You should not know about all the function. These are the basic function that you should know. In a very first place, for sure, you should practice all of those functions that I have mentioned over here. And yeah, after that, for sure, you will be able to pick and choose any kind of example or any kind of use cases, and you will be able to debug those use cases, and you will be able to perform all sort of a data manipulation or data addition, subtraction, or matrix operations, any kind of a matrix operation or any kind of array operation that you are looking for. Yes, it is possible to perform all of those array operation. So now what I will do is, so I will try to take some of the questions. I think we have already answered many questions from our side in your Q&A session. So I will try to take some of the live question from here, and if you have any kind of permutation combination, you can try this out by yourself, and then we can go ahead. So fine, guys, I'm going to unmute couple of you one by one. You can start asking question in a proper
Hello,
order.
Sudhanshu.
Hello,
Yeah,
sir.
go
Hello,
ahead.
Sudhanshu.
One
So
by one.
I have a 2D array.
Okay.
Okay. It is 3, 4, 5, 6, 7, 8, and 6, 7, 9. The one that you have used in example.
Yeah.
Fine. So you have basically array a double r like a double r a y, and
Yes.
you have array inside the array, right?
Correct.
Okay,
So
fine. So tell me, what is the element that you have?
just anything, sir. 1, 2, 3.
Okay, fine. 3, 4, 5, and then like 1, 2, 3. Fine.
Yeah. And one more, sir. One more array.
Okay, so okay, one more array you want me to give? Okay,
Yes, sir.
fine.
Yes.
So one more array I can give over here. So 3 comma 6
Yeah.
comma 7. Fine.
Yes, sir.
Okay.
Now, if I give like the shape of this one,
Okay.
this is giving me some like different kind of an output. I could not understand, sir, what it
Okay,
is.
fine, not an issue. So I'll try to explain you. It's not a big deal at all. So see, this is my array n, right? Now, if you are trying to give shape, right? Now, what is the meaning of shape? Shape means number of rows, number of columns, right?
Yeah.
So can I say that I have basically this array and 0, 1, 2, 0, 1, 2. So 3 cross 3. Is that fine?
Sir, sorry, sir. I missed the n dimensional. Like I want to convert it to a 10D. Like n dim equal to 10. You explained,
Okay,
right?
fine. You wanted to convert into a 10 dimension, right? See, shape is different and dimension is different. So suppose if I'm going to give n dim over here, so n dimension over here, right?
Yes.
So now it will look like this one. Okay.
Correct.
So
Correct. Yeah.
now this is the something that you're looking for, right? Okay. So now shape is going to be this one. So shape means dimension. What is the total number of dimension that you have given? So total number of dimension is equal to 10 that you have given, and I will try to take my previous array as well. Let's suppose. So I will try to take my previous array as well. So this one, and let me name these things as a n1 over here. So now n1 is this, and here if I'm going to print n1 dot shape, so it is trying to give me a total number of row and total number of columns. Now, what is the meaning of total number of row and total number of column? So here, can I say that this is a two-dimensional array?
Correct. Yeah.
It's a two-dimensional, right?
Yes.
If you will try to print a dimension, so what is the dimension it is going to return? Can I say that n1 dot n dim, it is going to give it two dimension? Now, what is the meaning of two dimension? Two dimension means x coordinate and y coordinate. Can I say that? X axis and y axis. So I will be able to represent my array over here. This is the meaning of this. Agree?
Yes.
Agree? What is the meaning of three dimension? Three dimension means I'm trying to expand these things into a z axis as well, right? So
Yes.
means I'm trying to add some array behind the array. So we have one array. So just try to understand in this way. So what is the meaning of three dimension? So meaning of three dimension is nothing but, suppose I have this diary, right? So I have one array. I have one array over here, right? Now, if I'm going to check another page over here, so I'm trying to create one array behind another array, right? This is called as a 3D. So this one panel is representing just a 1D, and then behind that it is representing a 3D. Now 10D means what? Practically 10D you will not be able to visualize it, right? So 10 dimension means what? So I have in a virtual space, I have basically these many number of the dimension. These many number of the dimension I have. Now, when I say 2D over here, when I say this is a 2D array, so with the help of x and y coordinate, I will be able to represent it. When I will try to say these things as a 3D array, it means in a breadth, towards a z axis also, I have some data set. When I say 10 dimension, so I can say that even into a 10 dimension, I have some kind of a data. That's the reason. So you will be able to get basically 10 element. 10 element means, let's one by one, let's try to understand it. Suppose if I'm going to create this array n1, and if I'm going to reshape n1 in this way, so n1 dot reshape, I would say into 1 cross 3 cross 3. Now, what is the meaning of this? Can I say that it has converted these things into 3D, right? Again, if I'm going to convert these things 1 cross 1 cross 4D, right? What is the meaning of 1 cross 1 cross 1 or 3 cross 3? 1 cross means I have basically one array, and inside that I have an array basically of 3 cross 3. What if I'm going to convert these things? I have total 9 number of elements. Let's suppose I'm going to give this as 3 and this as 1 cross 3. Now what happened? You will be able to find out that I have basically 3 array. What is the meaning of this? 3 array I have, right? Meaning of this one is I have basically 3 array of size 1 cross 3, right? I have basically 3 array. This is one array. This is another array, separated by comma. This is another array. And what is the size of every array? 1 cross 3, right? So if you are going to give a dimension, so for sure, whenever you will try to print a shape, right? So shape wise, it is going to give you 9 element itself. If you will try to multiply everything, it will be 9, means element has not changed, right? The only thing is, so it is trying to add a dimension in that one. So it is going, previously, like we had a 2 dimension, it has added a bracket, means it will keep on increasing a dimension into a virtual space. That is the meaning of this thing. It's exactly like the same thing, like a 3 dimension or 2 dimension, or maybe 1D we used to create. Is it making sense now?
Yeah, sure. Thank you so much.
Yeah.
So in 214, then we have taken a matrix when we are doing column wise addition.
Sorry?
So in 214,
214, okay, 214, yeah. Transpose that we have done.
नहीं ट्रांसपोज तो ठीक है सर, आपने वेक्टर को जब मैट्रिक्स में बदला था तो वो क्यों किया हमने, मतलब वो नहीं समझ आया।
वेक्टर को मैट्रिक्स में कहां बदला?
रीशेप कर दे, मतलब अगर हम जैसे ये मेरा एक रो वेक्टर है, मतलब रो वेक्टर है ना बेसिकली, तो अगर इसको हम कॉलम वेक्टर में कन्वर्ट कर दें डॉट रीशेप करके, मतलब तब वो पॉसिबल है?
See, reshaping, so if suppose I have like this one is a data, right? And let's suppose if I'm trying to find out, maybe let's suppose I'm going to perform this operation. So let me do that. Stop sharing and share again. Okay, so there was a 214.
सर वो 245 हो गया।
अच्छा, ओके, 245 हो गया, ओके, ठीक है। तो यहाँ पर we have like a n2 and it's completely fine, and now this is how this data set is. Now if I'll try to check a shape of this data, so let's suppose if I'm trying to check a shape of this data, this is the shape 1 cross 3, right? Now what I will do is I will try to do a reshape, and reshape means, so I can try to convert this things to 3 cross 1, right? Agree?
Yes, sir.
And
Yes,
then
sir.
now I'm trying to print these things. So can I say whatever I was able to achieve with the help of a transpose,
Same, yeah.
I'm trying to achieve exactly same thing with the help of this one. And further, if I wanted to do some kind of processing, I will be able to do it. So let's try to generate M over here. Done.
सर अगर मैं मैट्रिक्स ना दूं, सिर्फ वेक्टर दूं, तो हमारा वो कॉमा 3 होगा ना बेसिकली, मतलब
So if you are going to give just a vector over here, right?
right.
You are not going to give an element inside an element. Now let's try to understand what happens internally. So suppose if I have given this element, right? Now if you will try to check a shape of this one, shape is nothing but 3. It is trying to give you. Now if you will try to check basically like n dot dim of these things, so we have like a n2, so n2 dot ndim. So basically it's a one dimension. One dimension means what? So you are trying to add some element. So what is M? So can I say that M is a 2 dimension, right?
Yes, sir.
And N is what? N is 1 dimension.
One
N2 is
dimension.
1 dimension. You will not be able to perform a array multiplication operation, addition operation, division operation, subtraction operation with
Right.
a different dimension. Shape is different thing.
True.
So shape wise, if I have a shape, like a shape is like a dimension, if dimension is same, because see what happens is dimension, can I say dimension of M is equal to 2? Agree? Dimension of this entire array is equal to 2. Agree?
right.
Right? And even if I'll try to perform this operation, so dimension of even this one is 2. Can I say that? Dimension of this one is 2. So shape is different, but can I say that dimension is same?
Yes, sir.
So whenever you're trying to do a data addition operation or multiplication operation or division operation or any kind of a manipulation operation in terms of array or matrices, make sure that dimension should always be same. Shape is different, it's completely fine, but dimension should not change. Dimension means X, Y, and Z coordinates. In between, you're trying to do some kind of a multiplication. So that should not be changed at all. And that's the reason. So I've converted those things into a like a n dimension, and then I was trying to perform this addition operation.
सर
Broadcasting.
अगर मैं वेक्टर पे सर रीशेप लगाऊं 3 क्रॉस 1 का, तो वो डिमेंशन अपने आप बदल नहीं देगा?
Yes, it will be able to change the dimension for sure. So reshape is nothing but, so reshape always gets applied on any kind of array. So you can try to reshape it from anything to anything.
तो मतलब मैं अंदर वेक्टर पास करके रीशेप कर दूंगा तब भी चल जाएगा ना?
Exactly, it will work. See, whenever, this is what I was trying to explain in the last case, right? Suppose if I have this kind of a matrix, right? As of now, what is the dimension of this matrix? What is the dimension of M?
M 3 cross 4.
Dimension.
Sorry, 2.
2D, right? It's a
Right.
2D basically. 2 means x and y coordinate basically, right? Now let's suppose if I'm trying to apply basically a reshape function. So can I say that I can change the dimension as well, right? So maybe I can try to apply reshape SHAP over here,
12 cross 1.
reshape, and maybe I can try to give, so 1 cross 2 cross, total number of element is 0.3 is equal to 12, right? So maybe I can give 6 over here, or maybe I don't want to give anything. In that case, I will give -1. Can I say that I have changed the dimension by doing a reshape operation?
Yes, sir.
Exactly, right?
Yes, sir.
Yes, by doing, or even I can try to change these things into 10 dimension, 4 dimension. But what I'm trying to say is, so whenever you're trying to do some kind of a primitive operation with respect to an array, so dimension should always be same. The data element, or like the matrices or the array that you have taken, then only it will be able to perform those kind of operations. So you can't try to like perform a matrix multiplication or addition operation with element which is having a different dimension. Basically, dimension should be same. Shape could be anything. Generally, people get confused that, okay, fine, you said that dimension should be same and shape can be different. Sometimes people try to understand shape as a dimension and dimension as a shape. So make sure that you understand dimension as a dimension, and then you can try to check in this way. Yeah.
Okay, thank you, sir.
Yeah. Thanks.
NP dot line space में.
Okay. NP dot line space.
Yeah, there you had generated 0.5 numbers, right?
NP dot line space. So NP dot line line space. Yeah, tell me.
Yeah, it bracket 3, 7, 3.5. I just wanted to generate an
Okay, what is the element you want me to give?
3, 7.
3, 7. Okay.
And any floating number?
Fine. Any floating number you wanted me to give? Okay.
Yeah. Is it possible?
Do you think so? So what is the third element? No, let's just try to understand this particular function. It is not going to give you like an issue. It is going to give you a warning, right? Now, why it has given you a warning? If you will try to understand this particular signature of the function, so you will be able to find out that it always look for starting point. It always look for my stopping point. Agree? And
Yes.
it always look for the number. Means
Yes.
the number of the item that you are trying to generate. Now, number of item you have given as 0.45. Do you think any item in this entire world exists as a 0.45?
Oh, yes. Yeah.
Got it,
Yeah.
right?
Yeah, got it.
People ask you, okay, fine, give me 100 rupees. So what you will do? You will just if I'll ask you, okay, fine, give me 1.45 rupees, 1.45 rupees. So you'll give me 1 rupees, and then you will try to show this 1 rupees and then give it to me. No, right?
Obviously not. Yeah.
So, yeah, the same thing gets applied even over here.
Yeah. Thank you.
Yeah. Next question, please. Okay, fine, guys. I think we are done for today. All right. So we have discussed this NumPy things. NumPy is actually very much important in terms of all mathematical operation, and you will not be able to understand a significance of NumPy unless and until you are not into a data science or machine learning or deep learning, because if you are into this area, for sure, you will keep on using a NumPy, and NumPy is like some kind of a things which will always help you out, like to debug your code or to understand the entire neural network and how training happens, how it's going to build a model, what is a kernel inside that one, how data is trying to calculate it, how data is going to build, or it's trying to understand the pattern in the data. So everything you will be able to understand, and everything happens inside a neural network in terms of ND array itself, ND array or NumPy matrix itself. So just try to understand this part. And again, one more information, this NumPy is not only this much. NumPy itself is a very huge package, So there are thousands and thousands of a function which is available. But at the same point of a time, you should not know all those functions. It's completely fine. On a requirement basis, you will try to explore, you will try to learn, but these are the basic function which you should practice and which you should know. We are going to give you, I think we have already uploaded a Pandas practice assignment. And we are going to update a NumPy practice plus NumPy assignments. Both of these things we are going to update, and make sure that you're going to complete those assignments, and you try to complete all of those the practice session that we have given you. Probably by tomorrow it will be updated, and I think we have already updated the pandas. So keep doing those things and keep practicing those things. Next class, I will talk about Matplotlib, Seaborn, and Cufflinks and Plotly. So till then, so thank you so much for joining this class, and see you again in the next class. With that, have a great day and night ahead.